find equivalent capacitance between A and B, and given that all capacitors are C, can you find it? Don't do it. Can you find the equivalent capacitance between A and B given this circuit? What do we have to do? Same idea everywhere. This point is A. So jahan jai wire jai bodu A is the current, and you have to redraw the circuit. Okay, so this is A, this is B. How many separate wires are there? See, these are all one and the same wire. Yes or no? Yes. Similarly, this is all same wire here. This is the only different thing. Yes or no? Yes. Everyone sees there? Yes. So two are only there. So let's call these capacitors 1, 2, 3 and 4. So capacitor 1 is connected between which two? Left side A, right side B. Understood? Capacitor number 1, which is C. Tick. Or second. Second one. A here. Yes or no? And on this side there is B. So number 2 is also between A and B. Did you understand this? Yes or no? We are redrawing the circuit. આ કેપેસિટર ની એક પ્લેટ A ઉપર અટેચ, બીજી પ્લેટ B. Got that? Yes. Like this we have to redraw. So this is second turn. Third. This is A. So one plate A, second plate B. So once again, this is going directly to A. Clear? Yes. So this is number 3. And other one to B. Got it? Yes. Join over. One plate to B. And another plate to A. And then here is that is also A to B. Got it? The equivalent capacitance of 4C. What is the equivalent capacitance? 4C. આ circuit માં ભલે ગમે એ દેખાતું હોય, the truth is all the 4 are in parallel. Is that clear? So when we redraw things, it becomes easy to see whether they are in series or in parallel. Any questions? Yes. Louder. Okay. Look at second capacitor. Very present in the morning. Very present in the morning. Yes or no? So this is wire connected to A. So that same wire is going here. Yes or no? So all points on the same wire can be treated as same potential, right? So this is in here. So this capacitor is connected between A and on this side B. So that is this capacitor on one side connected to A and on the other side connected to B. Got it? Like that third one. This is A till here. So one side connected to A, the other side connected to B. Like that we draw them out. Fine. Right. So like this, we can often solve or simplify very complicated circuits also. Right? We can simplify complicated circuits. Like here, it doesn't seem very easy to judge, but when you redraw it, normally it becomes quite simple. Do you get that? Yes. Right? So that's the whole idea about point potential method. Alright? Along with it, another concept that comes in immediately once you realize about point potential is this short circuit. Often things are short circuited by mistake only. In practice by mistake. In theory, just to test your concept. Suppose someone says that here is a battery. Okay. And we have wires like this, for example. Each capacitor is C, each. Right? Then how much will be the equivalent capacity? What do you think? It will be only C by 2. It will be only C by 2. Why so? Have a look here. Starting at this point. Do you see this? Whatever point this is, call it X. And this is X, here up to here. Yes or no? All the way over there. So do you realize that these two capacitors are actually connected between X, that is same potential? Yes or no? Yes. Not very good. When that happens, when that happens, these two get short circuited. Basically, short circuited means on both sides the same potential is there, or on both sides the same wire is there. This same wire goes around and comes to this point. Yes or no? Yes. Are you seeing it? Yes. So that's why voltage for both of these capacitors is going to be zero. If voltage is zero, charge will also be zero. So they are useless capacitors. Did you understand? That is, whether they are there or not, it doesn't change anything in the circuit. Same thing about these two. Yes or no? Look at this. Goes on that other side as well. Clear? Absolutely. So whenever you have some capacitors, single or multiple, no problem. But when on both sides of it, you have the same potential. That means that capacitor will not store charge because its voltage. Whenever something is short circuited, its voltage becomes zero. So you cannot store charge. Did you get that? Alright. So remember this idea. Let's just solve a very simple question later. Suppose this is 2C, this is 2C. Okay. Can you find equivalent capacitance between A and P? 2C. What is the equivalent capacitance between A and P? 2C. It is 2C. Do you understand why? Yes. Yes or no? Yes. Because look at this. This capacitor, both the points are same. Yes or no? Yes. Do you see that? Clear? Yes. Everyone got that? This is X, then that's also X. It means this capacitor has zero voltage or zero potential difference. It means it will be of no use. Even if you remove it, meaning of the circuit or value of the circuit will remain same. So you can't know how much is equivalent capacitance between A and B now. Equals the same. Answer will be 2C. Got that? Okay, completely clear what happens in case of short circuits. Right? Okay, I am sure you will have a question. આવું તો શું કામ લગાડ્યું? પણ એ તો વાત છે. Short circuits are never deliberate. They are always by mistake. કોઈ હાથે કોઈ short circuit ન કરીને રાખે. તો પછી આ શું કામ લગાડી નહીં ને? If you want to do it in a short circuit. Right? So they are always by accidents. Right? Short circuits occur in circuits by accident. Okay? Fine. Now, some method of symmetry which are not very useful, but karavi do for completion. Okay, these are not very useful, but we can just cover it up. Let's see. Suppose you have got a circuit like this, and you want to find out what is the equivalent capacitance between point A and point B. Understood? So first of all, this is not Wheatstone. However tempted you might be to call it Wheatstone bridge, but it is not. I tell you the reason. I mean, if you just look at the upper part, it looks like that. Fine. Okay. Cross connection between the branch, but that's not it. From here on, there are few more things. That's why if you could separate it, then it would become Wheatstone bridge. You understand what I'm saying? If you could separate this point, then it might become Wheatstone bridge, but in its present form it is not. Now, look at this circuit. Okay. Do you realize that the point above and the point below are identical? What do I mean? Suppose let's say call this point X and this is Y. Do you agree that in every way point X and point Y are same? Yes or no? Yes or no? Sure or not sure? Sorry, but the same but nothing. Look at the circuit above this line. આ circuit ને આમ ઊંધી કરીને ડ્રો કર્યો તો આવું દેખાશે ને. You get what I'm saying? I hope you get it. Book હોય ને book ને આમ કરીને તો same જ રહેતી હોય. That's only possible if the point here and the point here are same. Clear? So what that means is, did you understand? Point X and point Y are same in every way. Is that clear? Point X and point Y are same in every way. Clear or not clear? Right? So what that would mean is that whenever charge is flowing, while these get charged, whenever charges are flowing and these get charged, so whatever happens above this will also happen below. Make sense? Whatever happens above will also happen below. Right? Okay. Now, what that essentially means is as follows: that this point is of no consequence. That is, here at this point, whether you take this above, I mean, if some charge flows, for example, here it goes to this point, the same amount of charge should flow here. Here or not here? Here or not here? Same amount of charge should go here. Got it or not? Sure. So what that would mean is that here the flow of charges is going to be opposite to each other. So in such cases, this middle point, right? Even if it is not connected to the vertical wire, it's going to be the same. Because whatever happens above, the same is going to happen below. Whatever happens above, the same happens below. So because of that, what you can do is, instead of having an actual connection at this point, you can separate the middle branch and you can draw it outside. What I mean is as follows. Here this contact is of no importance. See, this is still the same. That's what I've been telling you. Did you understand or not? What I am saying is that this section is separate. It will not have any effect on above or below. What have I done? I have joined A with 4, B with 8, and then I have joined 4 and 8. Actually, this joint was here, but why have I removed it? That's what I told you. That because we have symmetry, upper part and lower part is same, and this line is right in the middle. This was right in the middle. Make sense? Right? So whatever charge flows up, the same charge flows down. So even if this point doesn't touch it, nothing will change. Nothing will change. Think about this. Right? Whatever charge flows up, the same charge has to flow down. I hope you get it. You know how we're getting. You know how we're getting. This is one straight wire. If suppose 1 coulomb or plus 1 microcoulomb goes here, then over here it will be minus 1 microcoulomb. The same charge is going at both the places. Clear? Okay. So this way, now if you remove this connection due to symmetry, it becomes easy to solve this. Is this a Wheatstone bridge now? Yes. And balanced or not balanced? Balanced. So what to balancing is R the going. Did you get there? Did you get there or not? Right? So now what do we have? What do we have? These two are in, these two are in, and then that is in with these. Again, why did we remove it? Because, like I said, whatever charge flows up, flows down also. So So this circuit becomes symmetric, and when it is symmetric, the Wheatstone bridge gets balanced. Just a minute. Okay. So here what's your answer? Once we remove these two, 2 and 6 in series is 18 by 8. Sorry, 12 by 8 means 3 by 2. Okay. This is also 3 by 2. And then these two are in series again, so that is 32 by 12. So 8 by 3. Okay? Is this what everybody is getting?
Yes.
Yes or no?
Yes.
3 by 2 are no, 3 by 2 are no. Now 8 by 3. So that's going to be how much? LCM 12. Oh, sorry, 6. 6. So it's going to be 9 plus 9 plus 16. So that is 34 by 6. 17 by 3 micrometers. Understood?
Yes.
Okay or not okay? Yes. Now here we will use a slightly different kind of symmetry operator or symmetry usage. Have a look. This is very intuitive. Okay, prove करवा दो तो थाकी जाता, that's a fact. Right? So look at this circuit. Do you see that there is a line which is behaving just like a mirror? Yes or no?
Yes.
In this circuit. Clear or not clear? Absolutely sure. Okay. So if there is a line that's behaving just like a mirror, what that means is, if you find it for the left half of the circuit, and then the same thing on the right side. Yes or no? Okay. So one more thing that comes to mind is that if you forget about everything in in the upper branch or whatever that is, right? So then what we are having is that this point is right in the middle of A and B, so like that for X. And similarly this point here, right in the middle of A and B again, because the way X and Y are situated, Y થી જેવું આમ છે એવું જ આમ છે, yes or no?
Yes.
X થી જેવું આમ તેવું આમ છે, yes or no? That's why Vx will be equal to Vy, which will be equal to the average of A and B because of the symmetry. Right? Okay. So this point must be at half the plate. This point must be at half the plate. Someone's ready? No, someone's ready. No, ready. Series ma voltage divide, like, correct or not? So if I would say, if I take this one whole part, even if બીજો part છે ને બધો. So if the voltage for this is V, then for that one is also V. So total 2V થાય ને VA minus VB થાય. Make sense or not? Or not clear? પહેલા આ clear છે, Vx is equal to Vy or not clear? Yes, no?
Yes.
Yes? Okay, why is it exact average of A and B's potential? Because it is right in the middle. Suppose you think that there is only half of it. I hope we have drawn it. But is there drawn? So I was saying that whatever is the potential difference between A and X, do you realize the same should be the potential difference between X and B? જેવું આ left છે plot. Whatever is the potential difference between A and X, એવું જ ઓલી side છે? Yes or no? Sure, you get there? So that's why Vm minus Vx and Vx minus Vb should be same. Clear or not clear? So always do that. Vx equal to Va plus Vb by 2. So same is Vb. But you know, this value Va plus Vb by 2, that's not the main thing. એના માટે વધારે યુઝ કરી છે કે this is x and this is y, but Vx and Vy are same. What happens because of it? આટલું જ ફાઇન્ડ કરો અને પછી જે આવે 2 times in series, yes or no? Because after this the same thing is connected again. Make sense? Yes or no? After this the same thing is connected one more time. So it's like the two things are in series, not in parallel. Parallel get that. One is connected as a branch of the other, then it would be parallel. For example here. Right? They are identical but they are in parallel. Even આમાં શું થાય? આ અને ઓલું બે હતા. Those are identical but they are in series because they are connected side by side. I mean one after the other. Okay? So, using this idea, લખો હોય તો એવું લખી શકો in word. In a so, if a perpendicular bisector is like a mirror. Okay, if you want to use more technical language, you can say that if the circuit has a reflection, if the circuit has a reflection across the perpendicular bisector, or if I think mirror is an easier word to understand, that if the perpendicular bisector is like a mirror, then all points on perpendicular bisector are at same potential. All points on perpendicular bisector are at समझानो कि ना समझानो. So what we are saying is Vx is equal to Vy. Again, here we are using symmetry obviously. So ये वो है तो सुधा. Let's solve this circuit. but ये वो बीजो आते. Okay, can you solve this? If not directly, did you understand this? Why did I put x and y at the same? Because they will have same potential. Did you get there? Okay, so let's now label these capacitors and 1 get or 2 or 3 and 4. So first one. Okay, first one, and we don't know what this point is, and I can give you now because z. So there are 3 things here: a, z, and xy. Did you understand? Why did I call this a separate point? Look at this. Look at this point. Is it connected directly to A? No. Is it connected directly to Y? No. X? No. Can I attach nothing else? So it's a separate point. Did you get that? It is a separate point. So now we have A, we obviously have X, Y, and we also have Z. Got it? Now draw A, number 1. A. And what's on the other side of number 1? Z. Now, draw around. So this is number 1. So take 1 T. Now go to number 2. This we called as number 2. So number 2 is between Z and Y. So here Z, here Y. Can you draw? Easy. So what's the number 3? Z and X. So here Z and here X. Okay. You should generally draw all capacitors below or either above. બે બાજુ નહીં ડ્રો કરતા, it becomes confusing sometimes. એક લાઈન ડ્રો કરી એની નીચે ડ્રો કરો, કાં એની ઉપર ડ્રો કરો. Did you understand? Okay, third is done. Now what about fourth?
Yes.
A and X. So that's what I was saying. ऊपर से नहीं draw करिए, नीचे से draw. Is that clear? फोटो नहीं हो, ऊपर से draw करो तो आंसर तो ही जाए. But you might get confused. Okay, नीचे नीचे draw करो एक side तो easy पड़े. चलो, ये easy. देखा है? These two are easy. So CC 2C. But yeah, 2CC. 2C and C. CC નો થાય series માં છે 2C by 3 clear or not અને પછી આ તો આટલા પાર્ટ માં શું આવે આટલા પાર્ટ માં શું 5C by 3 clear everyone has been check confirm કર લો એટલા પાર્ટ માં તો 5C by 3 આવે this is not going to be the final answer of that question so this is 5C by 3 okay or not okay sure अच्छा तो हमें ओरिजिनल सर्किट ड्रॉ करो ना here is A and here is X Y and all that ये બે વચ્ચે 5C by 3 yes or no between A and X Y but on X Y is right side there was B અને ત્યાં આઉટ થાય ને so this is one more 5C by 3 yes or no yes did you understand what I am trying here on the right side of X Y જે હતું તો પાછું ડ્રો કરવું પડશે ને so that's why 5C by 3 over there also between X Y and B હવે આન્સર શું 5C by 6. Final answer of this question will be 5C by 6. Did you understand? Series માં છે ને if there are two identical in series it will become half. Capacitor માં એવું થાય ને is that clear or not? 2 microfarad હોય તો 1 microfarad. Okay. Method is clear. It's not like this method is universally applicable. એટલે એવું ન વિચારતા કે હા આપણે તો બધા કામ જ કરશું સરસ મેથડ પણ બધું હોય તો જ થાય. You have to read this sentence carefully. Is that clear? Shall I erase this question? Hopefully you will be able to make out what I have drawn. Okay or not okay? This is purely of academic interest. Okay. Kella capacitors? 12. Is that clear? 12 on 12 sides or rather edges of the cube. Barabar ke nahi? Sure. Okay. And suppose this is 1 point A and this is 1 point B. Okay, if all capacitors are C, remember if all capacitors are C as you should. Okay, then you have to find what is the equivalent. આમ એક કામ કરો આ બધું ઇન્ટરેસ્ટ એટલે ખબર પડી શું ચેન્જ કર્યો કે નો ખબર પડી here which points are going to be at same potential suppose આપણે લેબલ આપી દઈએ આ A B છે this is C no this is D E and suppose here is F G H and I then which points will be at same potential huh AD and what point which point will be at same potential D and E. D and E. Correct. D and E will be at same potential. Is that clear? Is that it? Okay, બીજું કઈ
I